So, hi everyone. So, let me see consequences for your real number 16. So, here there are some of the properties. So, those are very important. Okay. So, you see it because in these properties in my examination they have asked 2 more questions. So, you see it. Okay. So for A belongs to R, then prove that A into 0 is equal to A. So therefore I take here A into 0 is equal to A into 0 plus 0. Here I add 0 because your 0 is the additive identity. So I write in the place of 0 as A0 minus A0, that is additive inverse. So later using the additive associative law, so I write A0 plus A0 minus A0. So later using distributive law, that is A into B plus C is equal to AB plus AC. So using that I write A into 0 plus 0 minus A0. Using distributive law I write this. So this is equal to 0 plus 0 is additive identity. So using additive identity it can be written as A into 0 minus A0. Okay, A into 0 minus A0. So using additive inverse, A0 minus A0 is what? 0. Using additive inverse I write A0 minus A0 is equal to 0. Therefore A0 is equal to what? 0. And using commutative property we can write this A into 0 is equal to 0 into A. So in the both the cases we get the value 0. Therefore A into 0 is equal to what? A, or 0 into A is equal to what? 0. A into 0 is equal to what? A into 0 is equal to 0, not A. Okay, A into 0 is equal to what? 0, or 0 into A is equal to 0. Okay, this is a simple property. So using identity law, inverse law, associative law and distributive law we have proved this result. So next result is what? For all A comma B belongs to R, then prove that A into minus B is equal to minus of A into B. So therefore here I take A into minus B is equal to A into minus B plus 0. Your 0 is what? Additive identity. So using additive inverse, here I take A into minus B plus AB minus AB. This is additive inverse because AB minus AB is what? 0. So next using additive associativity, so I take A into minus B plus AB minus AB. So this is equal to what? So here I take using distributive law, so I take here A as common, so minus B plus B. So this is minus B plus B is equal to what? 0. Using what? Additive inverse. So A into 0 minus AB. Okay, so A into 0 is equal to what? 0, because by property 1 A into 0 is equal to 0, or 0 into A is equal to 0. So therefore using additive identity we can write this as minus of AB. So therefore A into minus B is equal to what? Minus of A into B. So this is the second result. Okay, this is the second result. So let me see your third result. So that is for all A belongs to R minus 0. So value of A is except 0 all real numbers. Then prove that 1 divided by minus A is equal to minus of 1 divided by A. Therefore here I take 1 divided by minus A is equal to 1 divided by minus A plus 0, because additive identity is what? 0. So using additive identity we can write this as 1 divided by minus A. So using additive inverse I take here 1 by a minus 1 by a, 1 by a minus 1 by a. This is equal to 1 divided by minus a plus 1 divided by a minus 1 divided by a. So using additive associativity, so I write here 1 divided by minus a plus 1 divided by a plus 1 divided by a minus 1 divided by a. So here I take multiplicative identity as 1. So then it will become 1 divided by minus a plus 1 into 1 divided by a minus 1 divided by a. So in the place of 1 I take multiplicative inverse, so then it will become 1 divided by minus a plus, in the place of 1 I write here 1 divided by minus a into 1 divided by a minus of 1 divided by a. So because 1 is equal to 1 divided by minus a into minus a becomes 1. So using multiplicative inverse I can write this. So here I take 1 divided by minus a as common, so then it will become 1 plus minus of a into 1 divided by a, this one minus of 1 divided by a, 1 divided by a, because of by distributive property, distributive law. So then it will become, this is equal to 1 divided by minus a into 1 minus a into 1 divided by a, because of additive inverse of a product, additive inverse of a product. So then this is equal to 1 divided by minus a into a minus remains what, 1 minus 1 minus of 1 divided by a, this term. So 1 minus 1 using multiplicative inverse it will become 0. 1 divided by minus a into 0 minus of 1 divided by a. So 1 divided by minus a into 0 using property 1, that is a into 0 is equal to 0, so it will become 0, minus 1 divided by a. Using additive identity we can write 0 minus 1 divided by a is equal to minus of 1 divided by a. So therefore 1 divided by minus of a can be written as minus of 1 divided by a. So this is your third property. So next property, that is fourth property. So that is, for all a comma b belongs to R, then prove that minus of a plus of minus of b is equal to minus of a plus b. So therefore I take minus a plus of minus b is equal to minus of a plus of minus of b plus 0. So this is your 0 here acts as your additive identity. So using additive inverse, a plus b minus of a plus b becomes 0. So using additive property I write here, that is equal to minus of a plus of minus b plus a plus b minus a plus b. So using additive associativity I take this term minus of a plus minus of b plus a plus b minus of a plus b. So using additive commutativity, so I write this as minus of a plus of minus of b plus b plus a plus can be written as b plus a using additive commutativity, minus of a plus b. So then this can be written as minus of a plus of, so here minus b plus a minus of a plus b. So because of additive associativity, so this becomes 0 because of additive inverse. Minus of a plus of 0 plus of a minus of a plus b. Using additive identity we can write minus a plus 0 can be written as minus a plus a minus of a plus b. So this can be using additive inverse we can write minus of a plus of a as 0 minus of a plus b. Using additive identity we can write this equation as minus of a plus b. So therefore minus of a minus of therefore minus of a plus of minus of b is equal to minus of a plus b. So this is your fourth property. So if you have any doubts regarding these four properties, you can send questions to my WhatsApp number, okay, and clarify your doubts. Thank you one and all.